So 3D printing's been around for quite a long time, but can we utilize that technology to permanently fix a firearm? The answer is yes, and today we're going to use that technology to permanently fix a common problem on an ISSC MK22 rifle. Well folks, nobody likes having a limp and floppy buttstock, but what seems to happen quite often on these MK22s from ISSC is the buttstock retaining button tends to break off from pretty cheap plastic and pretty poor quality engineering, in my opinion. So I'll give you guys an example of what happened here. As you can tell, the little end plate broke off, and how that happens on these rifles is pretty simple. This little button actually engages the buttstock, and there's not a lot of meat around the actual button itself, maybe about 1/4 of an inch of plastic. So when somebody actually steps on the buttstock or there's excessive force put on the buttstock itself, it tends to rip the button, thus breaking off this plate. So we're going to utilize 3D printing to reinforce this section of the buttstock, get a permanent fix for this thing, and get this back operational. Alright guys, so here's what I CAD drawn up on Fusion 360. Essentially what this thing is a end cap that's going to go around that button to help reinforce, give more meat around that buttstock button, and make this thing a permanent fix. Now I did also draw up a mounting screw, which we're going to utilize an M-lock screw, slightly modify the stock, and give this thing 2 mounting surfaces. And since it was kind of plain Jane, I decided to put the Punisher logo, make this thing kind of cool. Obviously when this thing's folded up, you'll be seeing this. So this program is called Cura. This is made by Ultimaker. Essentially what it does, it takes the CAD file STL, which is basically a model, and it slices it up for the 3D printer. Now if you don't know what 3D printing does, what it does, it actually prints in layers. So this thing will actually convert this model and slice it up to make layers and G-code files to print in paths along a horizontal line. So knowing that, if we slice this thing, I'll show you what it looks like on the preview. Obviously we got to put supports. There's a big gap here, so the printer is going to extrude the filament, polycarbonate. It's going to make layer lines, and if you don't have supports, what it's going to do is sag. So that's what that stuff is in the middle. And you can see here the little lines that it does. Like I said, it's just a very small nozzle that extrudes a little bit of plastic on a straight line. And this program takes the model and basically makes layer for layer until the actual complete 3D printed object is 3D printed. So knowing that the problem with that buttstock is having a lot of force being pushed up against the actual button itself, looking at the actual way this thing is actually sliced and layered, you'll see that it's following a horizontal line. Now this really isn't the best method if you want to actually reduce and mitigate that force. We want to go ahead and actually turn this thing perpendicular to where the force is being applied. So if the force is being applied straight up and down, these layer lines have a high tendency to actually delaminate, thus pretty much making this thing worthless. So we're going to go ahead and actually turn this model perpendicular and reslice this thing. So again, everything on this is, like I said, gravity takes force. There is supports to keep everything upright, and these things basically break off very easy. So here's the product sliced up on layer 89. Show you guys exactly what it looks like in the middle before the final product is completed. That lattice structure that you're seeing in the middle is actually called infill, and if you look closely, you can count the layer lines on the wall. Now, to increase the rigidity of this product that we're trying to make, we're going to increase the line wall count to 5, and also increase the infill to 80%. Reslice this thing and you'll see how much more material there is. Now, increasing the line wall count and increasing infill is going to obviously increase the print time, which gives it an estimate of 1 hour and 45 minutes total. But to go back to what we're doing, having an 80% infill actually really helps this thing get pretty strong. It's actually a lot stronger to have a little bit of air gap. That way it could take in force in all directions without it snapping. Kind of think of it as a Eiffel Tower. So we're going to go ahead and print this thing and show you guys what it looks like on a time lapse, and then install this part on the rifle. Alright, so here is the final product all printed out, ready to be installed. So I took the supports off and this thing came out phenomenal. As you can tell, the Punisher logo is on there and engraved pretty good. And this thing is super strong. Ugh. Yeah, I mean, it has a little bit of flex to it, but not much. I mean, obviously we could have made this thing out of steel or aluminum. It would have been a little bit stronger, but this is just shows the concept of using a 3D printer to CAD draw it up and get something actually working for now. And if this thing actually gets popular, I can actually take that CAD drawing and send it off to my machine shop and have it actually machined out on a CNC. So there's a big benefit actually using a 3D printer to pretty much prototype and sometimes even make a final product. So before we put this thing together, I went ahead and kind of modified the stock, put a little slot here for the M-lock T-nut that we're going to utilize here. So let's go ahead and put this thing together, see how she fits, and see if it actually fixed the problem. We'll insert the screw first and the M-lock T-nut here. Get that all lined up, ready to go. After that, let's go ahead and install the spring. Put the buttstock button on, and we're not going to do any kind of soldering or gluing. We're just going to put the end cap where it broke off as is. Put a little bit of pressure here, hold everything together, and then install the new modified butt plate adapter. Alright, pretty tight fit. Alright. Okay, so holding everything together, let's put the screw down to tighten up the buttstock here. So this polycarbonate stuff is pretty tough stuff. Playing around with this thing for over a couple months now, making all sorts of stuff with it. Okay, that's on there. I can let go of the button now. Let's tighten up the M-lock. And snug it down. Oh yeah, that feels good. And actually, that doesn't look too bad at all. What do you guys think? Should be able to slap it in there. Oh yeah, that sucker is working pretty good. So I'm going to say that that is a pretty good fix. Pretty solid. Kind of gives it a cool little aesthetic to the rifle now. And fixes a common problem on these rifles. MK22, basically a training rifle. Pretty badass, you know, kind of similar to a SCAR, but meant for training. And I think she's good to go now. Well, folks, utilizing 3D printing to fix firearms, imagine that. Well, guys, I want to know what you think. I want to see your guys' comments. Does 3D printing have a place in the world of firearms for repairs or add-ons? Let me know, comment below. As always, stay safe, happy shooting, and I'll catch you on the next one. Thanks for watching.